Hello guys, so this is Miss Figueroa. Tomorrow's test will cover slope in various forms, so finding the slope given an equation, given a table, given a line, anything like that, 2 points, and then also converting to slope-intercept form, which is our y equals mx plus b, and adding and subtracting polynomials. So we'll jump straight into it. I'm only going to do 1 or 2 from each section, so that way you all have some problems to do to review yourself. So I'm going to do number 2 and number 4 on this first section. So it says simplify the expressions by performing the appropriate operation. So by the appropriate operation, I mean by adding or subtracting, but we don't really know until we see the problem. So sometimes we'll see adding, sometimes we'll see subtracting, and sometimes we'll see both. So on number 2, we have 3x squared minus 3x minus 3x minus 3x squared. So we know that when we have minus, we distribute the negative, which is the same thing as saying we're going to change all the signs on that second one. So we'll rewrite the first one as 3x squared minus 3x, nothing changes. And then the second one, everything changes. So minus 3x plus 3x squared. So we have 3x squared plus 3x squared, which are our like terms. So we'll combine those, and that gives me positive 6x squared. And then we have minus 3x, which are two like terms, and they're both negative, so we're getting more negative. So we're going to add them together and keep that negative. So negative 3x minus 3x will give me negative 6x. And I've combined all my like terms, so that's my final answer, because we're not solving for anything, we're just simplifying. We'll do the same thing on number 4, but on number 4 we see that we have two different operations that we need to perform. So we need to be careful when we're doing these, just to make sure that we are changing the signs when we need to or keeping them the same when we need to. So on the first operation, plus, our signs will stay the same. So we'll rewrite this first one since nothing's changing here. And when we have plus, nothing changes. So plus 2x minus 1. And then on that last one, here we have to change the signs. So we'll have plus 3x minus 4. Now I'm going to be combining my like terms. I'm looking for the highest degrees, so the highest exponent that I have to go in the front, which would be a square. And I only have 4x squared. That's the only square. So when I write it, it's just going to stay the same. Nothing's happening to it. Then we have our x's, so 9x plus 2x plus 3x. So that's 9x plus 5x, which would be 14x's. And then lastly, our constants, so minus 1, minus 4. So that's more negative. We'll add them together, keep it negative. 4x squared plus 14x minus 5 is my final answer for simplifying number 4 on section 1. Now on section 2, we're finding the slope given equations. So when we're finding the slope given an equation, we want our equation to look like y equals mx plus b, because then this is my slope. So on numbers 1 and 2, they're already in slope-intercept form, so I'm not going to do either of those, but I am going to do number 4. So on number 4, we need to convert it to slope-intercept form by solving for y. Oops. So I'm going to move that 5x over first, so we can isolate the y. I still have 2y equals negative 5x with a positive 6, so plus 6. And again, I still have 2y. I need to get y by itself, so I'll divide everything by 2. We get y is equal to negative 5 over 2x plus 6 divided by 2 is 3. And it says find the slope. So if I'm just writing my slope, then m equals negative 5 over 2. Make sure that you keep the sign with your m. So since that had a negative in the front, we keep that negative with it. Also, just some clarification on when you're writing your answers. The test will be multiple choice, but in the future, whenever you're writing your answers, make sure you're not writing negative 5 over 2x as your slope. The x is a variable. It does not belong with the slope. So the slope is just the number, which would just be negative 5 over 2. Now in section 3, we're finding the slope given graphs. So two of them are, one's horizontal and one is vertical. So just make sure that you know your horizontal versus your vertical slopes. I'm going to do number 1 and leave y'all 2, 3, and 4. So on number 1, we're finding the slope given the graph. There's two ways we can do this. So we can either label our points and say that this is at the origin, 0, 0, and this one is 2, 1. And we can use our slope formula. And plug those points in, so I could say that this is x1, y1, this is x2, y2, and just plug those straight in, so we would have 1 minus 0 over 2 minus 0. 1 minus 0 is 1, 2 minus 0 is 2. My slope is 1/2. We can do it that way, or we can count. So when we count, we got to make sure we go rise over run. So we're going to count how many we're going up and put that over how many we are going left or right. So we're going up 1 and we're going over 2. So our slope still, when we count, is 1 over 2. So it does not matter which way you prefer. I just wanted to show you both ways in case you prefer one over the other. Now in section 4, we're finding the slope given a table. So when you're given a table, you can do two different things. And we're going to use table number 4. Oops. You can find, you can find the difference between your x's and then the difference between your y's and put them over each other. But I prefer to use the slope formula and just pick out any 2 points. So that's what I'm going to do. If you prefer to find the difference in the tables, then that's fine. So I'm going to find 2 points. I have 2, 1, and I have 4, 2. So we'll have y2, let's label them, is 2, so 2 minus 1, and then x2 is 4, 4 minus 2, 2 minus 1 leaves me with 1, 4 minus 2 leaves me with 2, my slope is 1/2. Then on section 5, find the slope of the line that goes through the given points. So now this is where our practice with the slope formula will come in handy. I'm just going to do number 1. Give y'all some practice with 2, 3, and 4. So our slope formula is right here. So we're going to label our points. We've got x1 and y1, x2 and y2. So y2 is negative 4 minus y1, which is 7, over x2, which is negative 6, minus negative 4. So be careful with those double negatives. Now we have negative 4 minus 7. We're getting more negative, so negative 11, over negative 6 minus negative 4, which we know is the same thing as negative 6 plus 4, so just be careful there. which will be negative 2. Negative 11 over negative 2 will not reduce, but we can knock out both of those negatives, so my slope would be positive 11 over 2. Now on section 6, it says write the equation for the line that goes through the given points. So on 5, we were finding the slope, and that was it, we were done. But on section 6, we're going to write the equation, which means we need a whole equation as y equals mx plus b. When we're given 2 points, we'll use y minus y1 is equal to m times x minus x1. And then we will convert that to slope-intercept form. So I'm just going to pick a random one. I'm going to do number 2. So first thing we want to do is label our points, x1, y1, x2, y2. We've got y minus y1. We're just going to use the first point for now. And that equals m, which we need to find by our slope formula. So you see how everything's tying together. Oops, x2. So we'll find our slope, 2 minus 1 over negative 17 plus 3. We would have a double negative there, which is 1 over negative 17 plus 3 is negative 14. So that goes where my m is. And then we'll continue x minus x1. So x minus x1 is negative 3. So double negative there. Now we'll solve this for y. So distribute that negative 114. And add 1 to both sides. Y equals negative 1 over 14. Let's see where my pen went. There we go. X. And then negative 3 over 14 plus 1 would be, I want to say positive 11 over 14. And that's our equation. We'll do one more, just so y'all can see it done again, since it is a lengthy process. We will label both points. Use our slope formula to find m. Oops. So y2 is negative 9 minus 9 over x2 7 minus negative 6. Negative 9 minus 9 is negative 18. 7 plus 6 is 13. It's got some funky fractions. So negative 18 over 13 will not reduce, so we'll just use that as it is. Y minus y1. So now we're looking at this equation to plug it in. Equals m. And then x minus x1, so x plus 6. Y minus 9 equals negative 18 over 13 x. So then we will distribute the negative 18 over 13 to that 6 as well, which will give me negative 108 over 13. And the problems on the test will not have crazy fractions like this, so don't be afraid of fractions, but also don't worry about them. So we have y equals negative 18 over 13x. So negative 18 over 13 is my slope. And then we have negative 108 over 13 plus 9, which is positive 9 over 13. And then on this final section, we have our applications, which are our word problems. We're going to do number 3 and 4. So number 3 says a painter must add the areas of 2 walls to determine the amount of paint needed. The area of the first wall is modeled by 4x squared, that should say squared, plus 12x plus 9, and the area of the second wall is modeled by 36x squared again, minus 12x plus 1. Write a polynomial that represents the total area of the 2 walls. So we have 2 walls that he's going to paint, and one has this first area and the second has the second area. If we're going to paint both walls, then we need to add both areas together. So to write that polynomial, we would have 4x squared plus 12x plus 9 plus 36x squared minus 12x plus 1. We would have area of wall 1 plus area of wall 2. And since it's only asking for us to write the polynomial, that we are done on number 3. Number 4 says write an expression that represents the perimeter of the shaded region in terms of x. So perimeter, we're adding all our sides together, and it is the shaded region, which is both of those rectangles, so we would have to add them all together. If this is a rectangle, I need to find out this side, which would be 3, and this one, which is 6. So this entire thing is 3 plus 6, which is 9. So I'm finding the perimeter of the shaded region, so I need to add this plus this plus this plus this plus this plus this. So the only one that I excuse me, the only one that I'm still missing is this one. So in order to find that one, I would take the full amount minus this piece that I know right here. So when we are writing the expression for the perimeter, we would have the ones that we know, so x plus 2 plus 3 plus 9 plus 6. So I've done this wall, this wall, this wall, this wall, plus 2x plus 5, and then plus 2x plus 5 minus x plus 2. So this looks crazy. It looks absolutely insane, but it is not that hard because right now, all we have to do is combine our like terms. So we're going to take it one tiny little step at a time. X plus 2 in the parentheses. Did anything change? No. So we're going to keep x plus 2 the same. 3 plus 9 plus 6, we can combine all three of those. So 3 plus 9 plus 6 is the same thing as 9 plus 9, which is 18. Now in the parentheses again, did anything happen to 2x plus 5? No. So plus 2x plus 5. Now this is where we get the changes, because we have 2x plus 5 minus x plus 2. So 2x plus 5 minus x plus 2, we would have 2x plus 5 minus x minus 2. So we're going to distribute that negative. 2x minus x, we can combine those already, or we can write it as it is, so plus 2x plus 5 minus x minus 2, and then combine from here. So I'm looking for all my x's. I have x plus 2x plus 2x minus x. So 1 plus 2 plus 2 minus 1. It's going to give me 4 x's. And then 2 plus 18 plus 5 plus 5 minus 2. So these are my constants, and I'm going to be adding together, combining them. So 2 minus 2, 5 plus 5 plus 18, we got 28. I could be wrong because I just did that in my head, but I do believe it is 28. And then the expression overall is just 4x plus 28. If you would have left it like this, that would have been fine because it only asked for the expression itself. But we like to simplify when we can, so 4x plus 28 would have been the better answer. Now, on number 4, on this last section, don't freak out if you had a hard time with it. I just wanted to test y'all on what you could do with regards to applications. So if we can use our brain and see what's going on with the shaded region and apply what we know about perimeter, I just want to see what we could do there. But this question in particular is not on the test. The idea of adding our polynomials and subtracting our polynomials, yes, that is on the test, but there is not a write an expression that represents perimeter of the shaded region on the test. So if you are freaking out saying, what in the world did she just do on number 4? It's going to be okay. I just wanted to test your knowledge and see what you were able to do on that one, but do be prepared to see one like those first 3. So then everything else is covered on the test. So do study up on those. Make sure you know how to find your slope given any form. So a table, a graph, a line that's not in slope-intercept form, a line that is in slope-intercept form, and then our points. Make sure that we can apply word problems and add, subtract polynomials. So then that is it for the review. Make sure that you get the rest of the problems completed and then turn that in on Canvas. And of course, study up before tomorrow.